Yeah, now recording is started. So good morning all and welcome to NLP Basics session. As Vivek has introduced, I worked as a data scientist in IBM and AI intern with Cellstat. So today I'm going to take you through NLP Basics and preparation of the text for the NLP. So let me share my PPT. Hope my presentation is visible now.
Yes.
Okay. So welcome once again and let's get started. So today we are going through NLP Introduction, Corpus and Corpora, Tokenization, Type Tokenization, Ngram, Bigram, Unigram, Lemmas and Steam, Stop Words, NLP R Programming, NLP Spaces, Summary, References and NLP Python Lab. So whatever we will be discussing, I will be taking you through the Python code. However, I would like to show you one feature of R programming model and SPSS model. So everyone, please keep your questions ready. At the end, after the Python lab, we will be discussing all your questionnaires. Or else, if you feel free, you can disturb me and ask the questions. So let's get today's objective. So what we are going to take home today? It's understanding of text preparation tasks such as corpus development, tokenization, lemmatization, steaming, stop word removal. So basically, this is very important for preparing the text for the NLP programming or advanced NLP. Once we understood these concepts, I will be taking you through the Python. Then what is language? So language is a means of communication that you, me, everyone talks to each other, get the information, understand the word. So the languages examples, all of we know as English, Japanese, Dutch, Hindi. There are many languages in India. One of the aim of the artificial intelligence is to build a machine that can understand commands in natural language, written and spoken. So computer which can do this will need the powerful hardware and sophisticated software. But teaching a language to a person or a computer is not an easy task. Basically, few days ago, I have learned another language. The person who is learning another language from the mother tongue, he or she will understand what type of pain it would be having, or what is the starting work we need to do to make a person understand a language. So basically here there are two problems like syntax, the rules governing the way in which words are arranged, or and the second one is understanding context to determine the meaning of the word. So to interpret even a small phrase require a vast amount of knowledge. For example, when I was learning the Dutch language, so even if I'm going to the market or I'm in the market, this is a small sentence, took me some more analysis coming to the Dutch. Okay, so this is how it is. So basic goal of natural language processing is to enable a person to communicate with computer in the language that they use every day. So how we understand and we talk and we feel, similar way computer should give us the understand and give us the output. This is what is a basic aim of the NLP. So natural languages that we all know, they are expressive and easy for us to use. Computer languages are C, C++, C hash, Java, Python, etc. All of us know this. They are easy for computer to understand, but they are not expressive. So what is NLP? It is a set of techniques used by computers to detect the human language the same way the human detects the language automatically. What does this mean is, like when human reads the text, he or she will immediately comprehend and understand and come up with the output, or come up with the replies and responses. For example, he or she will not break the sentence into the part of speech. He or she will not break the statement into the some common words, or he or she will not break the sentence into the people or the places. And also they will automatically understand whether the paragraph or a sentence is happy, angry, or sad. Coming to the Wikipedia definition, process of extracting knowledge and the information from language, from natural language, is the natural language processing. So where is NLP positioned in data science? So natural language processing, NLP, is a subpart of artificial intelligence, and it is with the linguistic concern with interaction between computers and human being. Specifically, it is the process of computer extracting meaningful information from natural language input and or producing natural language output. So basically what we want is like how human communicate without any hurdles. That's what that is how the computer also should communicate in the language wise. It also includes text and the speech based systems. If you see the figure, so it says natural language is a subpart of the artificial intelligence. However, it also interacts with machine learning and deep learning, which is another area of the data science, another study area of the data science. There are few applications of NLP I have listed here. Sentiment analysis, speech recognition, all of us knows as Alexa, Siri, voice assistant, and chatbot. Chatbot nowadays everyone know. During the COVID period, all problems of us has been solved by chatbot. For example, aeroplane reservation problem, we ping to chatbot. Then HR related issues, we ping to the chatbot of our own companies. And then there are many users of Amazon. Any issues with the delivery quality, we talk to the chatbot. So this is how the chatbots are in the every one of us know. There are few more: autocorrect, auto prediction, email classification and filterization, grammar checking and text summarization, advertisement to the target audience, translation, social media analytics, and the recruitment. Hope till here you are with me. Any questions before I proceed further?
So friends, feel free to bring your questions up.
Okay, then I will continue. So sentiment analysis is one of the example. It's a subset of natural language processing. Why I have taken this for the explanation is sentiment is everyone knows. It is a positive, negative, neutral emotions of all of us. So same way, NLP has to take out the emotions from the chunk of text. So it is also called as opinion mining. Sentiment analysis is widely applicable to reviews and social media for a variety of applications ranging from marketing to the customer service. This I will be demonstrating with Spss model. So let's go into the heart of today's topic. So as we know, like how human being understands and deliver the language as a communication media, computer will not be do that. It is very difficult. It is challenging problem for a machine. For example, just a keyword search will not give us the information of length of the word or length of the document. Hence, here it lies the importance of preparation of the text. So what are the various requirements we want to know is corpus, tokenization, stop word, part of speech, entities, analysis like emotion analysis, angry, happy, and sad. So let's go into the heart of this topic. So corpus. What is a corpus? The collection of the big text is the corpus. Entire data set is a corpus, or I can say entire Wikipedia is a corpus. And the plural is corpora. So for the explaining of the corpora, let's say it's the biggest data set or biggest text chunk let's say I can, for the explanation purpose, let me say that corpora is n number of document, like D1, D2, D3, D3 till Dn. Then every document will be break down to the paragraphs P1, P2, P3 till Pn. Then every paragraph will be break down to the sentences S1, S2, S3 till Sn. And then every sentence will be break down to the words W1, W2, W3. And then every word will be break down to the single character CH1, CH2, CH3 at CN, CHN. So this is what is the corpus. Corpus is usually contain raw text, which is in ASCII or UTF-8 format, and it also contains metadata associated with it. Corpus can be made up of everything from newspaper, novel, recipes, radio broadcast to television shows, movies, and tweets. Then coming to the tokenization. So what is tokenization? Tokenization is process of breaking the text into the small token is called tokenization. So one may view as a word is a token in a sentence, and the second one is sentence is a token in a paragraph. The classification of tokens are word tokenization, character tokenization, and subword tokenization. So word tokenization is an algorithm which divides block of text into separate words depending upon the delimiter. For example, I love my dog. It will break down to I love my dog is in the 4 tokenizing words. Similarly, this is a sample. After tokenization, it would have this is a sample as the 4 tokens in this sentence. Coming to character tokenization, similar way, the word listen will break down to LISTEN as each character being a token. Then subword Ngram tokenization that we will see in the next slide. There is something called as type tokens. So what is this type tokens? Type tokens are unique tokens present in corpus. So for example, in a corpus, if we have words like friends, Roman, and country, those are unique words in that entire corpus, then that can be the token, that would be seen as a token in our program. Coming to Ngram tokenization. So what is the Ngram tokenization? Is Unigram is one word, that is one word sequence, that is, for example, please. Bigram is 2 words, 2 word sequence like please turn. Trigram is 3 words, 3 word sequence, that for example is please turn your. And Ngram is a sequence of n words. Next is subwords, tokenization subword. So in some of the situations, subword information itself is very, very useful. So what happens, for example, the word menthol has OL in the suffix. It indicates a kind of alcohol. Then if the problem statement involves classification of organic compound names, then one can reuse the same code and treat every character as Ngram as a token. Coming to the program listed here, if you see name is menthol, and then with the for loop, I have ran it through the for loop, and the output has come up as a bigram character, that is MEETTHHAANNOOL. So we got OL. So furthermore, taking these bigrams, person can go ahead and do the programming depending upon the problem statement. Now lemmas and STEAM. Lemmatization. Lemma is a short form of it. It is a root form of the word. But lemmatization is a text normalization technique used in natural language processing. These algorithms has been studied since 1960. Lemmatization is a technique that switches any kind of word into its base root mode. Sometimes it might be useful to reduce tokens to their lemmas to keep dimensionality of vector presentation low. So this reduction is called as lemmatization. Coming to the example, lives after lemmatization, we'll get the word as LEAF. That is a root word of leaves. Leaves, we will after lemmatization, again we get the same word as leaf, LEAF. So this is a root word for both of them. Then coming to stem. Stemming is the process of reducing the word to its word stem, chopping of suffixes, or making it to or bringing it to the root words. It is an alternative to lemmatization and chops the ending characters. Example is studying. Studies, study. After stemming, we will get a word STUDI. So this is not the verb. Like STUDY is the verb, but it is not a verb. So it is the output of a stemming of studying, studies, and study. Then, what is the difference between lemma and stems? So, word change, changing, changes, change will give us the lemma as a CHANG, which is a root verb of all this change category. Whereas the stemming will give us the word CHANG without E, that is a stemmed word of this change category. So right hand side, we have few examples. Leaves give leaf as stemming, leaves give leaf as stemming, and lemmatization, just now we saw leaves and leaves give the root word LEAF. Then next is a part of speech. So what is a part of speech? It is a word along with its tag. For example, noun would have a tag as N, verb will have a tag as V, adjective will have a tag as A, adverb will have a tag as R. So there are few more tags available. So I have attached a reference link at the end. You can go and see more on that. Next is the stop word. So what is a stop word? These are commonly used words in the language. What are those? A, the, is, are, to, be, and etc. So stop words, they are commonly used and carry very little information. So it is advisable to exclude the stop words. However, for sometimes we do need the stop words. For example, phrase queries, King of Denmark, various song titles, let it be, then to be or not to be. Relational queries, flights to London. So here we need to do the trade-off, or we need to take the decision whether to ignore the stop words or we have to keep. That is depending upon the problem statement. So till now, whatever we have discussed, corpus till the stop. Here everything will depend upon the problem statement, and our programming or our thought process will work accordingly. There is not a hard and fast rule that one has to remove the stop words only. But if your problem statement demands it, you need to keep it. So this is what is the text preparation. Okay. Hope you people are with me. Is there any questions on this?
Ma'am, Bhakti ma'am, can you explain lemmatization and stemming again?
Yeah. So lemmatization is nothing but getting the root form of the word. Okay. So any word has been given, like here also, studying, study, study. It should give us study. So that is a root word. So any word given, if we do the lemmatization, it should give us the verb. It should give us the root mode. Okay. So it may be verb, it may be noun, whatever, but it should give us a root mode. Am I clear on the lemmatization?
Yes, ma'am.
Okay. Then next, coming to stems. Stems is basically a chopping process. So what it does, if you see this red color, right? So it chops from D, if you see, that is a common word we have. So it chops from that and it gives us STUIDI. So this is not actual verb, but it is a stemming. So one can use alternatively stemming to the lemmatization. So in the layman's language, lemma will give us direct root word, but stem will give us the word after chopping the ending characters. Am I clear on the stems?
Yes, thank you so much.
Yeah. So this we are going to see more on the Python lab. So that will be clear there. Any other question? Okay, then I will just proceed further. So as I said, I want to demonstrate one small feature in R. So whatever we have discussed, all these things like text preparation from corpus till the stop word has been used in the R programming model. This is the output of R programming model. So what I have given is, I have given the documents, like if you see on the right hand side, Brady till white taker, these all are the document which has the input to the R program. And what I'm getting this graph with the word count of each document. If you see, Brady is having a more than 6,000 characters in the document, and this you see 12,500. This is a document called home. So this is a word count we are getting through our program. And packages used here are TM, QDAP, OpenNLP, Stanford NLP. So whatever we have discussed, everything would be here, would be used in R also. And this is one feature of the word count I have shown you here. Then coming to the SPSS. SPSS is again a data science tool to give us the predictions. So this the diagram you are seeing on the screen, it is the input to the SPSS modeler.
So Bhakti, this SPSS is an IBM product. So is it similar to Power BI or Tableau, or it has a different role altogether?
It is a tool, Vivek, but it is different than the Power BI and Tableau. I have not worked more on Power BI and Tableau, but I know this SPSS have advanced functionalities, like it gives us three models, three predictive models that we can take it. Means initially, as you know, in the data science, we give the input and we keep tuning the model, so we get n number of modelings. Okay, but here that ensemblement model, there is a node which gives us three predicted models. Finally, through all three, means it is a handy for us to which we can economically optimally use for the program.
So SPSS uses machine learning, deep learning behind the scenes, or it uses traditional data analytics?
No, machine learning, it takes all the types of machine learning.
Okay.
I have one question. Can I ask?
Yes, please.
Yeah, I mean, SPSS is even before the machine learning came into being. It is like a pretty old statistical package used. So is it free? Because I think last time when I used it, it was not free. So is it free now?
No, it is.
Yeah,
it is not free. It is not free.
Yeah, that's what I was thinking. I mean, unlike R, it is not free.
It is not free. Okay. Any more questions? Okay, so I'll go ahead explaining this figure, what you are seeing. So basically, this is a market survey done on the new portable music player has been launched. So two questions has been asked in the market, like what most is liked in this music player, and second question is what list is liked in this music player. So this questionnaire is fed to the SPSS modeler model, and we get the output. So output is this sentiment analysis. So the figure right now you are seeing is the positive sentiment analysis. SPSS gives output in 4 quadrant. The first quadrant being, you can see the happy faces. So this is a positive sentiment. Second quadrant, it reads all the questions, make the n number of patterns and list type 1, type 2 here. Third quadrant, it will create the concept and it will grab only positive columns from this, positive things, rows and columns from this, and this concept too is been drawn on the first quadrant. Okay, and the fourth quadrant is much more detail of every question. Like if you see, the battery power is great. Its category is electronic and battery. So this is how the output of SPSS modeler with the positive sentiment. This is also called, some places it is called as a polarity check. Similarly, it also gives the negative sentiment. So same, whatever I explained, first quadrant, second quadrant, third quadrant, fourth quadrant, everything lies same. Only the third quadrant, it pulls all the negative statements, negative concept, and it builds the diagram on the first quadrant. Okay, this is what in the SPSS. Any queries, any questions till now? Okay, so till now what we have seen, summary of the session is we have seen the introduction of NLP, basic building block, text preparation. It is important. It is, we have to do the judgment also while doing the coding and all. Then we have seen the word count example in R, and we have seen sentiment analysis by SPSS. There are some more references I have given in the next slide for further reading. And now we'll head to the Python lab from here. Okay, so I'll just stop this and I'll start the Python lab.
So primarily in this session, Bhakti is covering, text preparation activity. And so this is the step before machine learning. Am I right, Bhakti? These are the steps before machine learning.
Yes. Like how any data science problem, once we have a data and we do the data understanding and data preparation, this is a step like that in the NLP as well.
Right.
So I'm doing demonstration on Sales Start Hub. It will take 2 minutes to restart. Till then, if anyone is having any questions, let me know.
So Bhakti, some of the newer, algorithms such as, BERT, Transformer, right, or even OpenAI. So any of those also help in data prep, or we still have to pretty much go through the NLTK steps here, natural language toolkit steps here, before we bring in the transformers or the BERT for advanced deep learning on text.
So whatever I have used is NLTK and Spicy only here,
Right.
and that is pretty much helpful. So before transformer and all.
Right. Okay.
Well, I have just one question regarding SPSS for the sentiment analysis and polarity.
Yes.
Is there any free alternative that I can use instead of SPSS? Because if it is there.
You want another programming language or SPSS?
No, as a free alternative to SPSS. I mean,
Yeah,
SPSS is, you said that
we can do it in the Python also. We can do it in R also. I am demonstrating that factor in Python right now.
Okay, thank you.
In Cellstrat Hub, we have a pretty extensive NLP pack, and which is free. And one of the projects there is on sentiment analysis.
Thank you.
It takes some time, 2 minutes of time to start up.
We have a full stack AI app also in Cellstrat Hub on sentiment analysis, which the link I have sent in messaging.
So as we know, corpus and corpora, big chunk of data sets. So we will see it here. And to work on this text preparation, we generally use Spicy as a library and NLTK. So it's up to you which one you want to use, but I will be showing demonstration with both of them. So this is how I have installed Spicy here. And if you are using Jupyter Notebook outside, then there will be an exclamatory mark like this. We have to install it. Otherwise, it will not get installed. Okay. Here in this program, we'll be seeing corpora, tokenization, Ngram, lemma, pause, and stop words. Okay, so with this spicy, it is pretty easy. Like import spicy, I have already installed. Import spicy. Then I'm loading the English library. This is a text I have given. Keep your face always towards the sunshine, and shadow will fall behind you. Okay, so I'm expecting the tokenization. As I said, tokenization will also include the delimiter. So if you see, it do have the delimiter as a token. Let me rerun this. Keep your face always. So every word is a token along with the delimiter. Even full stop also it has taken as a token. Okay, so same with the NLTK, import NLTK, and with this tokenizer, I'm importing tweet tokenizer. This is a tweet. This is basically text I have given. Spread love everywhere you go. And after tokenization, it is becoming spread love everywhere you go. And dot is also one of the token. Let me run this. Okay. And this NLTK is using a couple of corpus. So I'm using here as a Gutenberg and pin corpus here. It's already downloaded, Gutenberg and Pincut. So before going further, this tokenization, two examples are clear, right? With spicy and NLTK. Okay, then let's go ahead. So once it is downloaded, I want to see there are many text files in this Gutenberg corpus. So if I list it, here there are so many text files. Okay, now what I'm going to do is I'm pointing it to one of the text file. Here I have taken Austin EMA text file. Okay, and just for my my reference, I have just printed it. So it would be. So I have already pointed it to Austin here and printed the same here. Okay, now this EMA will be having all the tokenization. Just see, this EMA it is having this text, and all these are tokens of it, like EMA by Jan 1816 or till the end. Okay, now as I said in the beginning, like taking the word count would be difficult. So here is the word count. I have shown you in our programming how the graph represent, and here this we can get the word count of this entire text file. This is 1,92,427. Okay, hope all of you are with me till here. Then next we have seen is unigram, bigram, and trigram. So this is the function I have defined. Okay, and I have sent this tokenized word from here. See, if I have called the program, called a function here with this clean and 3. So if you see 3 is a trigram. Okay, so if I make it 2, it will become bigram. So now you see it is. So it comes spread love, then love everywhere, then everywhere you go, and go dot. Okay, if I put it 1 unigram, it would be one word in we get as a unigram. If I put 7 here, then I should get entire sentence. I have got entire sentence here. Okay, so this is what is this is our function definition. Okay, then with NLTK I am demonstrating it with the different text. I'm using the text as NLP starts with text preparation task. So 1 gram, I'll run this, and NLTK I'm using this word tokenizer to get the ngram, and let me show you the output of this. So if you see 1 gram, it is NLP starts with text preparation task. 2 gram, it will come up as NLP starts with text. Similarly, Trigram will be NLP starts with, and 4 gram will be NLP starts with text. Hope I am clear with this. Everyone is there with me till here?
Yeah.
Okay. Then next is bigram. So the subword tokenization, what we discussed, is I have given the name as a menthol. I have ran it through the for loop, and I got is the bigram. So I'll rerun it. Yeah, I've got OL. So with this, I can take it further depending upon the problem statement. Now coming to the lemmatization. Lemmatization is basically making the word to its root. So if you see, he has running, okay, running late. So I am expecting run would be breakdown to run. So if I run this, so I got this was is original. What is the root word of was? What is running is run, and what is late is. So I'm getting all the root words here. So this is with spicy. Then NLTK, lemmatization with NLTK. So I have to download this WordNet to do the lemmatization on the from the NLTK. So from NLTK stream, I have imported WordNet lemmatizer, and I have ran this. So now just see lemmatization of jumps, jumping, jumped, saddest, happiest, and easiest. So all these things would come to its root word. So if I run this, you can see jumps, jumping, jump would come up to root word as jump. And saddest to sad, happiest to happy, easiest to easy. See. So are you people with me? So these are the tags we have to give. See, what I need is if I need noun, it will come up as jump. So if you see, this is V. V is a verb. So jumping, the verb I need. The jumped, verb I need. This is what this is. This is pause tag. So whatever tag we will give it here, that output we can see. So whatever we expect, we have to give the correct tag here. Then coming to the stop word. So stop word, as I said, that common words. So with the NLTK corpus, I have imported the stop words, and through that, I am doing the I'm printing the stop words of it. So the text given is, this webinar is on introduction of natural language processing. So it should remove on, off, is. So if I run this webinar introduction natural language processing. So commonly used word has been removed here. So again, as I explained, like the stop word decision is depending upon the problem statement, whether to keep it or to remove it. And here also like lemmatization also. So what you need, whether you need verb, noun, what type of things you need, depending upon that you have to keep it. That the judgment has to be done on the problem statement. So POS tagging with the spacing. So if I see, this is the document I have given. Like I saw a girl with a telescope. So I have loaded the English directory, and then I have just if I run this spelling. So we have got this pronoun, verb, then girl is noun. So all these thing it has come up. So if it do not find anything, it comes up like JJ, I believe. Then coming to NLTK, I'll have to download the tagger to get the pause, that tagging, to get the POS. I need to download this, and after doing this, I will give the stop words with the English directory. Again, I will write the input. I saw a girl with the telescope, and here is the program to find the tagging of the sentence. So if I run this, you see this. I saw a girl with telescope. It has come up. I is preposition, saw is verb, and etc. So these details, as I said, there is one more link I have shared in the references, wherein we can go and see much more details about the tags. Okay, so okay, now coming to the thing, like again, stemming we have not yet discussed on this. So stemming, trouble, troubling, troubled. So what do you expect? It should stem the word till it common. So where is the common? Is till L, it is common. So it will stemmed it till the TRUBL. Let me run here. You are getting TRUBL. You are not getting the actual verb, but it is stemmed word of this series. Similarly, you can just see words. You can try all these things and do your research on that. So same is trouble here. And now lemmatization, stemming and lemmatization. If you do the lemmatization, it will come as TRUBLE. So it is a verb. Okay. So this is what I explained during the session. Hope now this is clear. Am I clear on the stem and lemmatization right now?
Yes.
Yes.
Okay. So this I have clubbed it together to demonstrate it. Trouble and PLE, printing, lemmatization, and stemming words. So leaf also, that we have discussed, right? So let me run this. Printing, stemming, nouns. So stem word. So it is leaf and leave it is giving. Whereas after lemmatization, leaves and leaves both are given it to the root word, that is LEAF. Is this also clear now?
Yeah.
Okay.
So there is a question. What is? Do we need both stemming and lemmatization, or one or the other is sufficient?
Yeah, the what during the session I've explained is like stemming is the alternative of the lemmatization. So it is up to the programmer's choice what he wants and how he wants to do it. So it's nothing hard and fast.
Okay.
So this is again part of which is repeating the code, but it is the same which I have demonstrated upstairs. Like again, I saw a girl with the telescope. So let's go ahead. Another 2-3 important things I wanted to demonstrate. So entity recognition. So during the session, we have come up like the human being understands a person or an organization or something like that, and even computer, we want computer also to give us the details. So with this with the Spss, if I'm loading this English library again, and this is a raw text I have given, so I want this raw text to be understood like a human being and give me the output. So the text here is, let me read it. The Indian Space Research Organization, or is the National Space Agency of India, headquartered in Bangalore. It operates under the Department of Space, which is directly overseen by Prime Minister of India, while Chairman of ISRO acts as the executive of DOS as well. So this entire statement, I want it to do the entity recognition, meaning whether it is a person or an organization, like that computer should come up. So this is the output. See, Indian Space Research Organization. This is the organization. Bangalore is the place. India is the place. Department of the Spss is again the organization. ISRO is again the organization. DOS is again the organization. So this is what is the entity, the way it comes up. Similarly, one more sentence I have given it here, and it has also came up with the entity. So you see that $74 million is a money. First is the ordinal. Mars is LOC. So all these things it will give us the information. And what we are doing it here is word dot label, that we are doing it here. So display C. So this is the display C, and we are taking this, and from there we are using this word dot label. Okay, then is the polarity check. Sir, you have asked me, right? Like, is there anything free which I can use for the polarity check? So see, this is the text I have given. The API is super easy to use and super useful for everyone who needs to do text processing. It is the best text processing web API and allows you to do amazing NLP without having to download or manage any models. Okay, this entire text I have given, and I have asked for the polarity scores here. Okay, this is an NLTK library, and in that I'm using the polarity score. If I run this, you can see neg is 0. So there is nothing is negative in this statement, in this entire text. Then 61.8% is the neutral and 38.2% is the positive. However, compound has given 97.5%. So what is this? Like, compound is a normalized sentiment score that you can see calculated in Weather package on GitHub. So this is the link where you can see the score. So this compound has calculated more than 97%. So NLTK has calculated our sentence to be very positive. So this entire text is very positive. Okay. So I have given the polarity check for negative sentiment also. See, here I have just written I am sad. If I run this, I am getting negative is 75.6% is the negative percentage. Neutral is 24.4 and positive is 0. And compound is minus 47.67. So this sentence is entirely negative. Okay. So am I clear in the polarity check? This is the free way we can check the polarity of a particular sentence.
Yes, yes.
Okay. Then the last section of this is we can download Indian language and do this corpus for any language. So if I download Indian language and I want to do it on Hindi, I have got is Purna, Pratibimbo, Hatao, Iraq, Sanyukta, all these things. Okay, I run this.
So there was a question on regional languages. So I guess this is one of the ideas.
Yeah, this is one of the ideas. So I'm not a okay. Is there any other question on this? So this is what is a Python demonstration is over. Any questions on this Python demonstration? So these are the references of whatever I have used for the program or for this deck. Python lab we have done. Now if any question answers, let me know.
There is a question in chat. What all Indian languages are available in NLTK?
That you need to search on that. What are there would be one reference I have given on that. You can check. All Indian language would be there. I have not have a cross check on that. So
Okay, any further questions, audience? So we don't share slides, but the recording of the session will be shared on our YouTube channel soon, right? So if you keep checking our YouTube channel, you'll get the recording. I'm sending you the YouTube channel link where all these recordings are posted. So this is the link which I've sent in chat. You can get the recordings, in a couple of days. And you can check almost 500 previous webinars recorded on that channel. Any other questions for Bhakti? Okay, so Bhakti, any final comments?
Yeah, that's it. Thank you everyone for joining the NLP basic course, basic session where I have spoke about the text preparation, basically the data mining part of it. So thank you so much for joining in the early morning Sunday.
So thanks, Bhakti. Some good comments are coming on chat if you were to see that. And
Yes.
very clear and presentation on basics of NLTK and NLP. So very well done. And look forward to further NLP sessions from you, Bhakti. And with
Yeah,
that,
sure.
with that, we come to an end of this webinar. Thank you all for joining, and so we'll see you in our future webinars. Thank you.